so this becomes A naught. And this is OR logic. So this point, the data is here, becomes A naught or B. And here becomes A naught or B naught, right? And then this is signal B, and this signal here, this at this point, becomes A naught or B naught, and the whole thing and B. All right. At this point, I'm not writing this down again, but I will just add a bar here because this is the inverse of the signal previously. And then the whole thing will end C, which will be this signal. And then everything will be ORed with B. And this becomes F. And now the task is just to simplify this part, or this logic equation, in order to simplify the circuit. And now let's start writing down the things. Keep in mind De Morgan's law, right? We covered this in the class. And De Morgan's law tells us that A or B naught equals, you split the bar and change the sign. So I have to split the bar in the middle. So we got two bars and change the sign. So change it from OR to AND. Okay, or if you have A, B naught, this equals A naught or B naught. You know, so now you just need to know this and memorize it and just use it. Okay, if you want to verify, it's very simple as well. Let's just have a truth table listed, and then for A and B, these two signals, you have these many possible combinations for all of them. And now let's compare. For example, I'm writing down A or B naught, and because I'm trying to verify that this equals, so A or B naught equals A naught and B naught, right? Because I want to split the bar and change the sign. And now I just verify it. And if you verify it works, then just keep using it. Don't think about this anymore. It takes time to verify it all the time, okay? And now let's take a look at it. If we have A and B both are zeros, and this becomes 1, okay? And this is 1 as well. If A, B is 0, 1, you got a 1 and not, you got a 0 here, and you got a, one of them must be 0, so it must be 0. The same to this one, okay? Both A and B's are 1s, and so A or B must be 1, and you put a not on the top, so it must be 0, okay? And same to this one, you got 0 and 0 is 0, okay? So you can see that the results are the same, so which means they are equivalent. So in that case, you can keep moving and verify the other one as well if you like. But I want to tell you that De Morgan's law is one of the most important laws you want to use in Boolean algebra. So let's just keep using it. Okay, now let's come back to this equation. We have A naught or B and naught. You can start from the big bar on the top, or you can start from the small part here. So let's see. If we start from the small part here, we have, you know, this is A naught or B naught, right? Let's follow De Morgan's law. So this must be A naught naught. So this is a bar getting split on the top, right? So I split it, and I have to change the sign. So I split the bar and change the sign. Okay, and this equals A and B naught. Because not is the same thing, it's still A. Okay, now we know that this part equals A and B naught. So let's just plug it in to the equation, and we're getting A and B naught, which is the part, this part at the bottom here, and followed by and B and C or B. Okay, since we know that we can combine these two, so this is B naught and B become 0, so 0 and anything will be 0, and then you invert it, so this becomes 1. So it becomes 1 and C or B eventually, or you can say B or C. So the entire circuit now becomes B, C, only 2 inputs, and an OR gate, and then F. Okay, so that's how the circuit is getting simplified.